Have you ever wondered what it would be like to travel through time? Imagine jumping forward to see the future, or going back to fix a mistake. What would that even look like? Time travel has fascinated humanity for generations, inspiring countless books, movies, and wild theories. But did you know there are actually different kinds of time travel? Join us as we dive into the 8 types of time travel, exploring how they work, their weird effects, and the incredible stories that come from them. So buckle up for a journey through the dimensions of time. Join us as we unravel the mysteries of time travel and discover what's truly possible. Fixed timeline theory, the unchangeable path. This theory is pretty straightforward. Basically, no matter what you try to change in the past, the future stays the same. You can go back and mess around all you want, but the timeline will always course correct to make sure everything ends up how it was meant to. It's kind of like time is set in stone. Imagine this. You go back in time to stop a disaster, but it turns out that in trying to stop it, you actually cause it to happen. Sounds frustrating, right? But that's the essence of this theory. Your actions in the past are already part of the future, and there's no way to escape that. Movies like The Terminator or 12 Monkeys are great examples of this, where the characters think they're stopping something catastrophic, but their actions end up being the very thing that makes it happen. The real mind-bender here is the idea that maybe everything is already written. Every choice, every action, it's all set in motion and we're just playing out the script. Is free will just an illusion? Are we all just along for the ride even though we feel like we're making choices? This fixed timeline concept raises all kinds of philosophical questions. If you can't change anything, does anything you do even matter? For some, that's a comforting thought. Everything is meant to be. But for others, it's unsettling, especially if you like the idea of having control over your destiny. To sum it up, the fixed timeline theory tells us that no matter what we do in the past, time will always find a way to make sure the future stays on track. It's kind of like a cosmic safeguard that keeps everything in line, whether we like it or not. Dynamic timeline theory, changing the future. This theory says that the past isn't set in stone, and if you go back and change something, the future does change. In this version of time travel, you've got the power to rewrite history, and that can have some pretty big consequences. A classic example of this type of time travel is Back to the Future. Remember when Marty McFly accidentally changes things in the past and his whole future is altered? That's dynamic time travel in action. You can tweak events and those changes ripple forward, affecting everything that comes after. It's exciting because it suggests you're not just an observer. You've got the power to make a difference. But here's where things get tricky. You've probably heard of the butterfly effect, right? It's the idea that even the tiniest change can have massive consequences. Step on a bug in the past, and maybe that small act changes the course of history, leading to a totally different present. It sounds far-fetched, but in the world of dynamic time travel, it's a real possibility. You never know how those ripples will play out. This type of time travel is all about responsibility. If you've got the power to change the past, how do you know what changes are the right ones? What if you make things worse? That's the big question here. Just because you can change things doesn't always mean you should. At its core, the dynamic timeline theory taps into our desire to fix mistakes and shape the future for the better. It's the ultimate what-if scenario, where every action you take could have far-reaching consequences. But with great power comes great responsibility, right? Multiverse theory, infinite possibilities. Multiverse theory opens up the possibilities. According to this theory, every time you make a change in the past, you're not altering your original timeline. Instead, you're creating an entirely new one. It's like taking a fork in the road and both paths exist simultaneously but in different universes. So, in this theory, there's not just one timeline. There are infinite timelines with every possible version of reality playing out somewhere. You might go back and change something in the past, but all that does is create a new branch of reality. Your original timeline stays untouched. Imagine stepping into a world where major historical events played out differently. Maybe dinosaurs never went extinct or humans never invented the internet. Crazy, right? This concept is used in a lot of popular media. One example is in Avengers Endgame, where the heroes travel back in time, but instead of changing their timeline, they create alternate ones. In this kind of time travel, every choice creates a new version of reality. The cool part is, every possibility exists, which means somewhere out there, there's a universe where you made a completely different decision than you did in this one. But this also makes you think, if there's an infinite number of realities, does anything matter? If there's a version of reality where every possible outcome plays out, does your particular timeline even matter? It's a wild thought, and it forces you to think about your place in the universe. Overall, the multiverse theory doesn't just limit time travel to fixing the past, it's about exploring whole new worlds, each one different from the last, and the possibilities, well, they're endless. Time loop, the endless cycle. This type of time travel traps you in a cycle where you live the same events over and over again. There's no jumping to the future or past. You're stuck in a loop, reliving the same moments until something or you changes enough to break out of it. A lot of you might be familiar with this from the movie Groundhog Day. The main character is stuck living the same day on repeat, over and over again, until he figures out how to live it differently and escape the loop. Another great example is Edge of Tomorrow, where a soldier keeps reliving the same battle until he can find a way to win. What's interesting about time loops is that they offer a chance for personal growth. You're given infinite chances to get it right, to perfect your actions and decisions. At first, it's frustrating, but eventually it becomes an opportunity. The loop almost forces you to evolve, to become the best version of yourself. But here's the big question. If you're stuck in a time loop, do your choices even matter? If everything resets at the end of the loop, does it matter what you do? This kind of time travel makes you think about the value of your actions and whether or not they have lasting consequences. In the end, a time loop can be both a curse and a blessing. It's a trap, but it's also a chance to learn and grow. And if you can break free, maybe you'll come out of it a better person, or maybe, just maybe, you'll be stuck forever. Quantum leap consciousness time travel. This theory is a bit different. Quantum leap time travel, where it's not your body that travels through time, but your consciousness. You don't physically jump through time, but your mind does, taking over someone else's body in a different era or moment in time. One of the most famous examples of this is the TV show Quantum Leap. The main character, Dr. Sam Beckett, leaps through time and takes over the bodies of people in different periods, trying to fix what went wrong. It's like he's jumping into someone else's life and playing out their role. But he keeps his memories and knowledge. This type of time travel is fascinating because it's not just about jumping through time, it's about experiencing life from someone else's perspective. You're forced to adapt quickly to a new body, a new life, and a whole new set of circumstances. And you have to figure out how to fix things before moving on to the next leap. But that raises some big ethical questions. If you're controlling someone else's body and making decisions for them, is that fair? Do you have the right to interfere in their life, even if you think you're helping? It's a tricky moral situation, and one that makes this form of time travel particularly unique. In quantum leap time travel, the focus isn't so much on the science, but on the emotional and moral growth of the traveler. It's a journey of self-discovery, as much as it is a journey through time. Alternate reality travel, diverging from the main timeline. This theory is pretty wild because it's not just about jumping through time, it's about jumping into a completely different version of reality. In alternate, you visit a version of the world where key decisions play out differently, leading to an entirely different timeline. This isn't about creating new timelines like in the multiverse theory, it's about seeing how one change in the past led to a radically different present. Think of shows like Fringe, where characters explore parallel realities to stop major disasters. Or imagine visiting a world where major historical events like the American Revolution or the moon landing never happened. In this type of travel, you're not just an observer of a different timeline, you're part of it. You might even encounter alternate versions of yourself, which raises some big questions about identity. If another version of you exists, what does that say about your current self? Are you just one of many possibilities? What's also interesting is that alternate reality, the fragility of history. A single decision or event can lead to a different outcome, making you wonder how much of our world is shaped by chance. In conclusion, alternate reality travel lets us explore the what-ifs of history. It's about more than just time. It's about seeing how different choices lead to different futures, and it forces us to confront some deep questions about identity and faith. Causal loop, the paradox of self-creation. The causal loop, also known as the bootstrap paradox, is where things get confusing. In this kind of time travel, events are caught in a loop where the cause and the effect are the same. It's like a never-ending cycle with no clear beginning or end, and the traveler might end up being the cause of the very thing they're trying to prevent. One of the best examples of this is the movie Predestination, where the main character discovers they're responsible for several key events in their own life. The same kind of loop appears in Harry Potter when Harry goes back in time with the time turner and ends up saving himself. In both cases, the actions they take in the future were always a part of the past. Then there's the bootstrap paradox, which is when something exists without an origin. Imagine going back in time and giving Shakespeare a copy of his works, and he publishes them. But where did the works originally come from? They exist in a loop, without a clear point of creation. This type of time travel raises big questions about free will and fate. If you're part of a loop, are you making choices, or are you just playing out a script that's already been written? It's a paradox that challenges the way we think about cause and effect. In the end, the causal loop is one of the most mind-bending forms of time travel, where time folds in on itself, and everything you do is both the cause and the result of the same event. It's enough to make your head spin. Time dilation, traveling through time by slowing it down. This theory is grounded in real-world science thanks to Einstein's theory of relativity. It happens when someone or something moves at speeds close to the speed of light, causing time to slow down for them compared to everyone else. So, while the person traveling at near light speed experiences time more slowly, the rest of the world keeps moving at a normal pace. In theory, this could allow you to travel into the future. You wouldn't jump ahead instantly, but by the time you return to normal speed, everyone else will have aged much faster. It's like fast-forwarding through time. A great example of time dilation is in the movie Interstellar. Remember how on the planet near the black hole, time moved much slower? For every hour spent on the planet, years passed back on Earth. That's time dilation in action. It shows how time can warp in extreme environments, especially where gravity or speed plays a big role. This isn't just science fiction either. It's been observed in real-life experiments. Astronauts on the International Space Station experience time slightly more slowly than people on Earth because they're moving so fast. While the difference is tiny, it proves that time dilation is real. Time dilation is fascinating because it offers a way to travel through time, though only forward. You can't go back, and once you move ahead, there's no reversing it. Still, it's one of the few forms of time travel that's possible according to the laws of physics. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Have you ever gazed at the moon and wondered about the secrets it holds? From its role in shaping life on Earth to its stunning features visible even from millions of miles away, the moon is more than just a celestial companion. It's a world of wonder, with mysteries waiting to be unraveled. Are you ready to dive into 10 incredible things about the moon? Join us as we explore its fascinating facts, ancient impacts, and surprising characteristics. The moon was formed by a massive collision. One of the most fascinating aspects of the moon's origin is its dramatic creation story. Scientists believe the moon was formed around 4.5 billion years ago when a Mars-sized object named Theia collided with Earth. This cataclysmic event ejected a massive amount of debris into space, which eventually coalesced to form the moon. Evidence of this giant impact hypothesis lies in the moon's composition. Lunar rocks collected during the Apollo missions show a remarkable similarity to Earth's mantle, suggesting that both celestial bodies share a common origin. This finding has helped scientists piece together the violent history of our early solar system. The moon's formation played a pivotal role in Earth's evolution. The massive collision tilted Earth's axis, creating the seasons we experience today. Additionally, the moon's gravitational pull helped stabilize Earth's rotation, preventing chaotic wobbling that could have drastically altered our planet's climate. While we now have a clear idea of how the moon came to be, there are still ongoing studies aimed at understanding the finer details of its formation. Space missions and advanced simulations continue to shed light on the early years of Earth and the moon's shared history. The moon's birth story isn't just about its formation. It's a testament to the dynamic and often violent processes that shape the cosmos. Understanding this dramatic event helps us appreciate the interconnectedness of celestial bodies within our solar system. The moon influences life on Earth. The moon is more than a distant companion. It plays a critical role in shaping life on Earth. Its gravitational pull is the primary force behind ocean tides, creating the rhythmic rise and fall of water levels that have been vital to coastal ecosystems for billions of years. These tides, influenced by the moon's phases, help regulate marine life cycles. From coral spawning to the behavior of fish and other sea creatures, the moon's pull sets the pace for life in the ocean. Without the moon's steady influence, these ecosystems might not have developed as they have. The moon also impacts Earth's rotation. As the moon's gravity interacts with our planet, it slows Earth's spin by about 1.5 milliseconds per century. While this seems insignificant, it has a profound cumulative effect. Millions of years ago, a day on Earth was only about 18 hours long, but thanks to the moon, we now enjoy 24-hour days. The moon's presence in the night sky has also influenced human culture, from mythology and literature to calendars and rituals. Ancient civilizations carefully observed their phases to track time, plan agricultural activities, and guide navigation. The moon's impact on life extends far beyond tides. It's a silent but ever-present force that shapes our environment, culture, and daily rhythms. Without it, Earth as we know it would be an entirely different world. The moon has a far side, not a dark side. The far side of the moon has often been misnamed the dark side, but this is a common misconception. Both sides of the moon experience day and night cycles, just like Earth. The far side is simply the part of the moon that faces away from Earth due to tidal locking. Tidal locking means the moon rotates on its axis at the same rate that it orbits Earth, causing one side to always face us. This phenomenon is why we only see the familiar features of the near side, like the Sea of Tranquility and the Tycho crater, while the far side remains hidden from view. The far side of the moon was first glimpsed by humans in 1959, thanks to the Soviet Luna 3 spacecraft. This side has a rugged, heavily cratered surface, starkly different from the near side's smoother, darker plains. The lack of Maria or lunar seas on the far side is attributed to differences in crust thickness and volcanic activity during the moon's early history. Exploration of the far side continues to provide valuable insights. In 2019, China's Chang'e 4 mission became the first spacecraft to land on the far side, uncovering data about its unique geology and deep craters that could hold clues to the solar system's formation. The mystery of the moon's far side captures the human imagination, reminding us of the unseen wonders that await exploration in our cosmic backyard. The moon is shrinking. The moon is slowly shrinking as its interior cools. This cooling process causes the moon's crust to contract, resulting in the formation of cliffs called lunar scarps. These scarps can rise as high as 300 feet and stretch for miles across the lunar surface. NASA's Lunar Reconnaissance Orbiter has captured images of these scarps, revealing that they are relatively young in geological terms, just a few 100 million years old. Some scarps even show evidence of ongoing activity, indicating that the moon is still geologically dynamic. This contraction has caused occasional moonquakes. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes occur due to the moon's shrinking crust and the gravitational pull of Earth. While they are not as intense as earthquakes, moonquakes can last much longer, sometimes up to 10 minutes. The shrinking moon also provides clues about its thermal evolution. Scientists study the size and distribution of scarps to understand how the moon's interior has cooled over billions of years, offering insights into the thermal histories of other rocky worlds. The shrinking process is a reminder that even celestial bodies we consider static and unchanging are constantly evolving. The moon continues to surprise us with its ongoing activity and the secrets it holds beneath its surface. Moon dust is surprisingly dangerous. The lunar surface is covered in a fine layer of dust known as regolith. While it may look harmless, this dust is surprisingly dangerous. Lunar regolith is composed of tiny, sharp particles created by billions of years of meteoroid impacts, which have pulverized the moon's surface. During the Apollo missions, astronauts discovered firsthand how problematic moon dust could be. It clung to their suits and equipment, and even got into the lunar module, causing respiratory irritation and damaging seals on spacesuits and machinery. The jagged edges of lunar dust particles make them abrasive, posing a significant challenge for future lunar missions. Prolonged exposure to these particles could harm both humans and equipment, necessitating innovative solutions for dust mitigation. Despite its dangers, lunar regolith has potential scientific and practical applications. It could be used as a building material for future lunar habitats or as a source of oxygen through chemical processing. Researchers are exploring ways to harness this abundant resource while mitigating its risks. Moon dust serves as a reminder of the challenges and opportunities that await humanity as we prepare to return to the moon. The moon is slowly drifting away from Earth. The moon isn't as stationary as it might seem. It's actually moving farther away from Earth at a rate of about 1.5 inches per year. This slow drift is caused by the gravitational interactions between Earth and the moon, specifically the transfer of angular momentum due to ocean tides. Tidal forces create a slight bulge in Earth's oceans, which exerts a gravitational pull on the moon. This pull adds energy to the moon's orbit, causing it to spiral outward over time. Though the change is gradual, it has profound implications for Earth and its future. As the moon drifts away, its impact on Earth's tides diminishes. Over billions of years, this could lead to less dramatic tidal changes, which might significantly alter coastal ecosystems that rely on the moon's gravitational pull. Additionally, the moon's distance affects solar eclipses. A more distant moon will appear smaller in the sky, eventually making total solar eclipses a thing of the past. This phenomenon also tells scientists about the Earth-Moon system's history. By studying lunar rocks and Earth's geological layers, researchers have pieced together how the moon's gradual drift has influenced Earth's rotation and climate over millions of years. The moon's drift reminds us that even the most familiar celestial bodies are not static. They are part of a dynamic and ever-changing universe with ripple effects that extend across space and time. The moon has an atmosphere, but it's extremely thin. Contrary to popular belief, the moon does have an atmosphere, but it's so thin and fragile that it's called an exosphere. This exosphere is composed of rarefied gases, including helium, neon, and argon, which are present in trace amounts compared to Earth's dense atmosphere. The moon's exosphere is constantly being replenished by several processes. Solar wind particles, micrometeoroid impacts, and the slow release of gases from the lunar surface all contribute to this tenuous layer. Unlike Earth's atmosphere, the exosphere doesn't provide protection from radiation or support for breathable air. Because of its lack of a substantial atmosphere, the moon experiences extreme temperature swings. Daytime temperatures can soar to 260 degrees Fahrenheit, while nighttime temperatures plummet to -280 degrees Fahrenheit. Without an atmospheric buffer, there's nothing to distribute heat evenly or shield the surface from direct solar radiation. This thin exosphere still holds valuable scientific insights. For instance, studying the moon's exosphere can help scientists understand the behavior of gases on other airless celestial bodies, such as Mercury and certain moons of Jupiter and Saturn. The moon's delicate exosphere highlights the challenges of future human exploration and settlement, as well as the ingenuity required to adapt to its harsh environment. The moon experiences moonquakes. Just like Earth experiences earthquakes, the moon has its own seismic activity, known as moonquakes. These quakes were first detected during the Apollo missions when astronauts left seismometers on the lunar surface. Unlike earthquakes, which are caused by tectonic plate movements, moonquakes have different origins. Moonquakes can be triggered by the gravitational pull of Earth, meteorite impacts, thermal expansion from sunlight, or the moon's internal cooling and contraction. Some of these quakes can last for an extended period up to 10 minutes because the moon lacks the water-rich rocks found on Earth that help dampen seismic vibrations. There are 4 types of moonquakes: deep, shallow, thermal, and those caused by meteor impacts. Shallow moonquakes in particular can be quite powerful, reaching magnitudes of up to 5.5 on the Richter scale, enough to cause structural damage if humans were living on the moon. Understanding moonquakes is essential for designing safe habitats for future lunar missions. Structures must be resilient enough to withstand these quakes and other environmental hazards. Moonquakes reveal that the moon is not as geologically dead as we once believed. It's a reminder that even a seemingly barren world can have dynamic internal processes that are crucial for scientists to study. The moon has water, but it's trapped in ice. The discovery of water on the moon has been one of the most groundbreaking revelations of the 21st century. In 2009, NASA's Lunar Crater Observation and Sensing Satellite, LCROSS, mission confirmed the presence of water ice in permanently shadowed craters at the moon's poles. These craters, located in regions that never receive sunlight, act as cold traps where temperatures can drop below -400 degrees Fahrenheit. At these frigid conditions, water molecules become frozen and remain preserved for potentially billions of years. This water ice holds immense significance for future lunar exploration. It could be used as a resource for drinking water, oxygen production, and even rocket fuel through the process of electrolysis. The ability to harness lunar water would make long-term habitation and deep space exploration more feasible. Scientists are also studying the origin of this water. It could have been delivered by comets and asteroids, or formed through chemical reactions between solar wind particles and the moon's surface. Understanding its origin provides insights into the history of water in our solar system. The moon's icy reserves symbolize untapped potential for human exploration and survival, paving the way for a new era of space travel and scientific discovery. The moon might hold clues about Earth's early history. The moon is often referred to as a time capsule for Earth's early history. Because it lacks weather, tectonic activity, and a thick atmosphere, its surface has preserved ancient features and records that have been erased from Earth over billions of years. Lunar rocks and soil provide clues about the early solar system. By studying the moon's composition, scientists have learned about the bombardment of asteroids and comets that occurred during a period known as the Late Heavy Bombardment. This era shaped not only the moon but also Earth, potentially delivering water and organic compounds critical for life. The moon's surface also offers a record of solar activity. By examining isotopes in lunar rocks, researchers can reconstruct the history of the sun's radiation and its effects on the inner solar system. Additionally, the moon's relatively unchanged crust holds information about Earth's early crust and mantle. Comparing the two bodies helps scientists understand how the Earth-Moon system has evolved over time, including the dynamics of Earth's magnetic field and plate tectonics. The moon's preserved history acts as a window into our past, reminding us that studying our closest neighbor can uncover secrets about the origins of our planet and the conditions that made life possible. The moon is a celestial treasure trove of mysteries and wonders, each fact revealing a deeper connection between our planet and its natural satellite. From its drifting orbit to the water hidden within its craters, the moon is far more complex and fascinating than it first appears. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the universe's wonders with us.
Did you know that beyond Neptune lies a mysterious region of space that holds the keys to understanding the origins of our solar system? The Kuiper Belt, often overlooked, is a treasure trove of icy worlds, hidden secrets, and cosmic enigmas. What lies within this vast expanse, and why is it so vital to the story of our universe? Join us on this cosmic journey as we reveal 7 little-known facts about the Kuiper Belt, unraveling its mysteries one by one. The Kuiper Belt is home to Pluto and other dwarf planets. The Kuiper Belt is a vast icy expanse beyond Neptune, home to some of the solar system's most intriguing small worlds. Among these is Pluto, the famous dwarf planet that continues to captivate us despite its reclassification. The Kuiper Belt is a treasure trove of rocky and icy remnants from the solar system's early days, holding secrets about planet formation. Alongside Pluto are other fascinating dwarf planets like Haumea, Makemake, and Eris, each with unique characteristics. Pluto, for instance, is a dynamic world with icy mountains, smooth plains, and evidence of past glacial activity. Its largest moon, Charon, is so massive relative to Pluto that the pair are often called a double dwarf planet system. Haumea stands out with its elongated football-like shape, caused by its rapid rotation. Makemake, with its bright, reflective surface, shines prominently in the Kuiper Belt. Eris, nearly as large as Pluto but much farther out, played a key role in redefining Pluto's status as a dwarf planet. These icy worlds defy expectations, revealing active surfaces, diverse atmospheres, and complex orbits. They challenge our understanding of how celestial bodies evolve over time. Far from being a static region, the Kuiper Belt is an evolving frontier, brimming with surprises. Each new discovery reshapes our perspective of the solar system and its history, showcasing the rich diversity of these distant objects. The Kuiper Belt serves as a reminder that even the farthest reaches of our solar system hold mysteries waiting to be unraveled. It's a relic of the early solar system. The Kuiper Belt isn't just an icy region in the distant reaches of our solar system, it's like a time capsule from the very beginning of everything. Picture this. Over 4.5 billion years ago, our solar system was just a swirling disk of gas and dust. While planets like Earth, Jupiter, and Neptune formed from that material, not everything got used up. Some of it stayed behind, untouched and frozen in time, way out past Neptune. That leftover material is what makes up the Kuiper Belt, a snapshot of the solar system's chaotic infancy. What's so incredible about the Kuiper Belt is that it contains some of the oldest and most pristine objects in the solar system. These icy bodies, untouched by the sun's heat or planetary collisions, are like fossils, holding clues about the building blocks of planets and the processes that shaped our cosmic neighborhood. Scientists believe studying them offers a backstage pass to the solar system's origin story, showing how everything came together billions of years ago. One reason the Kuiper Belt is a hot topic in astronomy is its insights into planetary formation. The objects, called Kuiper Belt objects, KBOs, range from a few miles across to nearly the size of Pluto. By analyzing them, scientists unravel how planets grew from tiny particles into complex worlds and study the chemistry of the materials present when the solar system was just forming. What makes the Kuiper Belt even more exciting is that it's not unique. Similar belts have been found around other star systems, suggesting these regions are a universal feature of planetary formation. By exploring the Kuiper Belt, we're not just learning about our own solar system, we're uncovering patterns that apply to planets across the galaxy. The Kuiper Belt serves as both a time capsule and a bridge to understanding the universe, connecting our solar system's story with the larger narrative of planetary systems everywhere. It's a reminder that even the most distant regions of space hold the keys to unlocking our cosmic origins. Preserved in ice and rock, the Kuiper Belt offers an unparalleled glimpse into the universe's ancient history. The Kuiper Belt is vast and mysterious. The Kuiper Belt is one of the most fascinating yet mysterious regions in our solar system. Imagine a gigantic, donut-shaped zone filled with icy objects stretching far beyond Neptune. Spanning billions of miles, this vast frontier remains largely uncharted despite our advances in space exploration. Even though much of the solar system has been mapped, the Kuiper Belt feels like an unsolved puzzle waiting to be decoded. This icy expanse is home to countless objects, from tiny fragments of frozen debris to massive dwarf planets like Pluto and Eris. Scientists believe we've only scratched the surface of what's out there. While a few thousand Kuiper Belt objects, KBOs, have been identified, there may be hundreds of thousands, or even millions of these icy worlds scattered across this region. Each KBO is a time capsule, preserving unique secrets about the early solar system, and forming part of an extraordinary cosmic tapestry. Studying the Kuiper Belt is no easy feat due to its incredible distance, faint light, and the cold, dark vacuum of space. Observing these distant objects is like trying to find a tiny firefly in a dense, dark forest. Yet, missions like NASA's New Horizons, which gave us a close-up view of Pluto and its neighbors, have started to lift the veil. Every discovery answers some questions while raising new ones, such as what forces shaped this region and whether unseen planets could be lurking there. Scientists believe that billions of years ago, the migration of giant planets like Jupiter and Neptune scattered smaller objects, forming the vast and chaotic Kuiper Belt. This process explains its strange, tilted orbits and offers insight into the dramatic forces that shaped our solar system. The Kuiper Belt is a reminder of how much we still have to learn, holding the promise of discoveries that could reshape our understanding of the universe. It's the birthplace of short-period comets. The Kuiper Belt isn't just a distant icy frontier, it's also the birthplace of short-period comets. These comets, which return close to the sun every 200 years or less, create the iconic bright tails that streak across the sky. When you see a comet like Halley's or Encke's, you're witnessing a cosmic visitor that began its journey in this distant region of our solar system. The Kuiper Belt is packed with frozen objects made of rock, dust, and ice, remnants from the formation of the solar system. Occasionally, the gravitational pull of outer planets like Jupiter and Neptune disrupts the orbits of these objects, sending them on a new path toward the Sun. As they approach, the Sun's heat vaporizes their icy surfaces, releasing gas and dust to form glowing comas and stunning tails. Each time you see a comet, you're witnessing the Kuiper Belt's icy fingerprints. Short-period comets follow predictable elliptical orbits within the plane of the solar system, unlike long-period comets from the Oort cloud that arrive from all directions. These differences offer scientists valuable insights into the forces shaping our cosmic neighborhood. Short-period comets are like ambassadors from the Kuiper Belt, giving us a glimpse into its icy world. Studying these comets unlocks the solar system's history. Their material, largely unchanged for billions of years, makes them time capsules from the dawn of the solar system. By analyzing their composition, scientists learn about the conditions that existed when planets were forming. The next time you see a comet lighting up the night sky, remember it's a traveler from the Kuiper Belt, carrying ancient stories from our cosmic past. The Kuiper Belt extends beyond what we can see. The Kuiper Belt extends far beyond what we can see, and its sheer size is mind-blowing. Imagine a region that begins just past Neptune, about 30 times the distance from Earth to the Sun, and stretches to nearly 55 times that distance. This colossal expanse is packed with icy worlds, dwarf planets, and countless smaller objects. What's even more fascinating is that this might just be the beginning. Evidence suggests the Kuiper Belt transitions into the scattered disk, a more distant and chaotic region, like the edge of a cosmic ocean fading into the unknown. Studying something so massive and distant is a monumental challenge. The Kuiper Belt's objects are small, dim, and spread out, making them incredibly hard to detect even with the largest telescopes. Yet, astronomers persist, uncovering new Kuiper Belt objects, KBOs, and piecing together a puzzle of the solar system's outermost frontier. Despite these efforts, the Kuiper Belt still holds far more secrets than answers. The greatest challenge in exploring the Kuiper Belt is its vast distances. The New Horizons spacecraft, which gave us a close-up look at Pluto, took nearly a decade to reach its inner edge. Exploring deeper into this icy region would take even longer, requiring extraordinary patience, planning, and technology capable of enduring deep space's harsh conditions. The Kuiper Belt is more than just a boundary. It's a potential key to unlocking the history of the solar system. Studying it might reveal how the planets formed and evolved, shedding light on mysteries we've pondered for centuries. Could there be a hidden ninth planet influencing the orbits of objects in this region? The Kuiper Belt sparks curiosity and pushes the boundaries of exploration, reminding us there's still so much about our cosmic backyard to uncover. Kuiper Belt objects may hold clues about Planet 9. Kuiper Belt objects might hold the key to solving one of the greatest mysteries in modern astronomy, the hunt for Planet 9. Imagine a massive planet lurking in the farthest reaches of our solar system, so distant and dark that we can't see it directly. Yet the strange orbits of certain Kuiper Belt objects, KBOs, are offering clues. These objects follow unusual, tilted or clustered paths, almost as if they're being tugged by an unseen force, possibly Planet 9. Astronomers believe this hypothetical planet, potentially up to 10 times the size of Earth, could be hiding beyond the Kuiper Belt. Its gravitational pull might be influencing the orbits of KBOs, creating patterns that wouldn't exist otherwise. It's like ripples on a pond. You might not see the pebble, but the ripples reveal its presence. Similarly, Planet 9 could be revealing itself through gravitational ripples in the Kuiper Belt. The search for Planet 9 is a monumental challenge. The Kuiper Belt is vast, and Planet 9, if it exists, would be incredibly distant, dim, and slow-moving. Finding it is like spotting a grain of sand on a beach at night. Scientists are using advanced telescopes like the Subaru telescope in Hawaii to scan the sky, while also mapping KBO orbits to pinpoint where Planet 9 might be hiding. Every new Kuiper Belt discovery adds another piece to this puzzle, making the search one of the most thrilling in astronomy. If Planet 9 is found, it would completely reshape our understanding of the solar system. It could explain the strange behaviors of certain KBOs and offer insights into the formation of the solar system's outer regions. Even if Planet 9 remains elusive, the Kuiper Belt itself remains a treasure trove of secrets, reminding us of how much we have yet to uncover. The idea of a hidden giant lurking at the edge of our cosmic neighborhood is a thrilling call to explore the unknown. And just imagine what we might discover next. The Kuiper Belt could redefine the search for life. The Kuiper Belt might change how we search for life in the universe. For years, scientists have focused on planets in the Goldilocks zone, where conditions are just right for liquid water and life. But what if the secrets of life lie in the icy, distant reaches of the Kuiper Belt? This isn't just a region of frozen rocks and dwarf planets, it could harbor the ingredients for life, potentially reshaping our understanding of where life can exist. One exciting possibility comes from subsurface oceans. Objects like Pluto and its moon Charon might have liquid water buried beneath their icy crusts. Even in the cold Kuiper Belt, tidal forces and radioactive heating might keep hidden oceans warm enough for microbial life to survive. If Europa or Enceladus, moons closer to us, are considered potential hosts for life, why not similar objects in the Kuiper Belt? Adding to the intrigue are the organic compounds found on some Kuiper Belt objects. These complex molecules are the building blocks of life, suggesting the chemistry needed for life might exist beyond planets. Discovering such compounds frozen in time could offer a glimpse into how life began, not just on Earth but anywhere in the universe. It's like finding a cosmic time capsule, untouched for billions of years, that could unlock the secrets of life's origins. The Kuiper Belt challenges the assumption that life needs a warm, Earth-like environment to emerge. Signs of habitability in this icy frontier would force us to rethink where we search for life, making even the cold, dark corners of the cosmos just as promising as sunlit zones. The Kuiper Belt reminds us that the universe doesn't follow our expectations, and that's what makes exploring it so thrilling. That brings us to the end of our deep dive into the Kuiper Belt, a realm that continues to surprise and intrigue scientists with its secrets. From ancient relics of the solar system's formation to the tantalizing possibility of hidden worlds, the Kuiper Belt challenges what we know about our cosmic neighborhood. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep reaching for the stars and uncovering the universe's greatest mysteries. What if I told you Earth isn't the best place to live? Out there in the vastness of space, scientists have found exoplanets that might be even more habitable than our own. Planets with endless oceans, glowing red skies, and maybe even alien life. But could we ever move there? And what if something is already calling them home? Stick around as we explore 8 exoplanets that could be more habitable than Earth. Kepler 452b. Imagine a planet that's been chilling in the habitable zone for 1.5 billion years longer than Earth. That's Kepler 452b, often called Earth's cousin, and for good reason. It's about 60% larger than our planet, meaning gravity would be slightly stronger, but hey, that's just an excuse to get those intergalactic gains, right? Now here's where things get interesting. Kepler 452b orbits a sun-like star, and it's smack dab in the Goldilocks zone, the region where liquid water could exist. You know what that means? This planet might have rivers, oceans, and maybe even life. Scientists believe its atmosphere could be thicker than Earth's, making it better at trapping heat. So, technically, it could be even more habitable than our home. But there's a catch. It's 1,400 light-years away. That's so far that if aliens from Kepler 452b watched Earth through a super telescope, they'd be seeing the year 624 AD right now. Wild, right? So, could we ever move there? Well, unless we figure out faster than light travel, it's not happening anytime soon. But Kepler 452b is proof that planets like Earth exist out there. Kepler 442b. What if I told you there's a planet that might actually be more habitable than Earth? Meet Kepler 442b, a super-Earth located 1,206 light-years away. It's about 33% larger than Earth, meaning it has more room for potential life, bigger oceans, and maybe even thicker forests if life exists there. Now here's where things get mind-blowing. Scientists say Kepler 442b scores higher on the habitability index than Earth itself. Why? Well, first, it orbits a much cooler and longer-lasting star, meaning life there could thrive for billions of years more than on Earth. Plus, its position in the habitable zone is almost perfect, meaning it gets just the right amount of sunlight to support liquid water, a key ingredient for life. And get this, since Kepler 442b is rocky and not too big, Its gravity would be similar to Earth's. No weird bone-crushing forces or moon-like jumps. If humans ever made it there, we might actually feel at home. But there's a catch because of course there is. It's super far away, making travel almost impossible with today's tech. But who knows? Maybe one day future explorers will land on Kepler 442b and find something waiting for them. Kepler 62f. Imagine a planet 40% larger than Earth, orbiting a distant star 1,200 light-years away. Now picture it covered in vast oceans, endless clouds, and maybe even alien islands. That's Kepler 62f, one of the most promising exoplanets for habitability, and possibly life. What makes Kepler 62f so special? First off, it's in the perfect spot, the habitable zone of its star, where temperatures could allow liquid water to exist. And here's the wild part. Scientists believe it might be a water world, a planet almost entirely covered by oceans, stretching for thousands of miles in every direction. Imagine deep, dark waters hiding unknown creatures, or maybe even intelligent life swimming beneath the waves. But here's where it gets eerie. Kepler 62f orbits a much cooler, dimmer star than our Sun. This means its daylight might be soft and red, casting long shadows over its endless seas. It also means that, if any life exists there, it might have evolved very differently from what we know. Could we live there? Possibly. If it has land, or if we build floating cities, Kepler 62f could be humanity's ultimate oceanic escape. But one thing's for sure, if something's already lurking in those waters, we might not be alone when we get there. Kepler 186f. What if there was a planet just like Earth, but with a red sky and an alien sun? That's Kepler 186f, the first ever Earth-sized exoplanet found in a star's habitable zone. If we could visit, it might feel eerily familiar, yet totally alien. Kepler 186f is about 500 light-years away, and is almost exactly the same size as Earth. That's rare. Most exoplanets we find are either way too big or too small, but this one? It's just right. And because it's in the habitable zone, temperatures might allow liquid water, meaning life could exist there. But here's the twist. Kepler 186f orbits a red dwarf star, not a sun-like star like ours. So what does that mean? Well, the sky wouldn't be blue, it would be red or orange. The plants, they might not even be green. Scientists believe that on planets around red dwarfs, plants could absorb different kinds of light, making them black, purple, or even blood red. Imagine walking through an alien jungle under a dim reddish sky. Spooky, right? The biggest challenge? Red dwarfs are notoriously violent, throwing out powerful solar flares. If Kepler 186f doesn't have a strong atmosphere, it could be a dead world. But if it does, it could be the most Earth-like planet we've ever found. TRAPPIST-1e. Alright, imagine a planet the same size as Earth, in the perfect spot for life, part of a system with not one, not two, but 7 Earth-like planets. Welcome to TRAPPIST-1e, one of the most exciting exoplanets ever discovered. TRAPPIST-1e orbits a red dwarf star just 40 light-years away, which in cosmic terms is practically next door. It's almost the exact size and mass of Earth, meaning gravity would feel normal, and if it has an atmosphere it could hold on to liquid water. That's huge. Scientists even believe TRAPPIST-1e might have an Earth-like climate, making it one of the best candidates for habitability. Now here's where things get weird. A year on TRAPPIST-1e is only 6 days long. Yup, 6 days. That means its star looks way bigger in the sky than our sun does, and days might last forever, literally. Because of a phenomenon called tidal locking, one side of the planet always faces the star, while the other is stuck in eternal darkness. The best place to live? Right on the twilight zone where light and dark meet, creating an eerie, endless sunset. Could we move there? If TRAPPIST-1e has an atmosphere and water, it might just be the best place for humans outside our solar system. Proxima Centauri b. If Earth ever becomes unlivable, where do we go? Well, Proxima Centauri b might be our best shot. Why? Because it's the closest exoplanet to us, just 4.24 light-years away. In cosmic terms, that's practically next door. If we develop ultra-fast space travel, this could be humanity's first real chance at colonizing another planet. So what's it like? Proxima Centauri b is about 1.3 times the mass of Earth, and orbits in the habitable zone of its star, meaning it could have liquid water. Scientists believe it's rocky, which makes it even more promising. But here's the weird part. A year here lasts only 11 days. Yep, the planet whips around its star way faster than Earth does, but there's a catch. A big one. Proxima Centauri is a red dwarf, and not just any red dwarf, it's a wild one. It throws out violent solar flares that could strip away an atmosphere. If Proxima b doesn't have a strong magnetic field, it might be a barren wasteland instead of a second Earth. Still, the fact that the closest star to us has a planet that could support life, that's huge. If we ever get serious about interstellar travel, Proxima Centauri b might just be our first stop. LHS 1140b. If Earth ever becomes uninhabitable, we might need a backup planet, one that's big, rocky, and stable. Well, meet LHS 1140b, a super-Earth that checks a lot of those boxes. It's about 1.6 times the size of Earth, but here's the kicker, it's 6.5 times heavier. That means it's dense, possibly packed with metal and rock, and could have a strong atmosphere, a crucial ingredient for life. LHS 1140b orbits a quiet red dwarf star about 40 light-years away. Unlike many red dwarfs that blast their planets with deadly radiation, this one seems calm and stable, giving life a much better chance. And the best part? It sits right in the habitable zone, meaning if it has an atmosphere, liquid water could exist on the surface. But here's where things get really wild. Because it's so massive, its gravity would be nearly 3 times stronger than Earth's. Walking there would feel like you're wearing a 100-pound backpack at all times. That means any life that evolved on LHS 1140b would likely be short, stocky, and incredibly strong. Imagine hulking alien creatures adapted to their high-gravity world. Yeah, we're definitely not arm wrestling them. Could humans survive there? If we can handle the gravity, LHS 1140b might just be one of the most promising exoplanets for colonization. But what if someone's already there? Wolf 1061c. Imagine a world 4 times the mass of Earth, sitting in the habitable zone of its star, where temperatures could allow for oceans, forests, and maybe even alien civilizations. That's Wolf 1061c, an exoplanet just 14 light-years away, one of the closest potentially habitable planets we've ever found. Now, here's where things get really strange. Wolf 1061c orbits a red dwarf star, which means its sky might be bathed in an eerie red glow, making everything look surreal. And because it's so close to its star, it might be tidally locked. One side forever scorched in daylight, the other trapped in eternal darkness. The only livable area, the twilight zone, where day and night meet, creating a never-ending sunset. But there's a mystery. Scientists believe Wolf 1061c may have gone through a greenhouse effect like Venus, meaning it could be a steaming, uninhabitable wasteland. Or it might be just right with a thick atmosphere and liquid water, we just don't know yet. Could it support life? Maybe, if it has a stable climate and an atmosphere thick enough to shield it from deadly solar radiation, Wolf 1061c could be one of the best places for us to settle outside our solar system. So could one of these exoplanets be our next home, or are we truly alone in the universe? As technology advances, we're getting closer to answering these questions. But until then, the possibilities are endless. Which of these exoplanets fascinates you the most? Let me know in the comments. And if you love exploring the future of science and space, don't forget to like, share, and subscribe to InnoVision Tech.